Hello students, in this lecture we will see fourth numerical on nodal analysis. The problem statement is determine the value of current flowing through 5 ohm resistor and 5 ohm resistor is present over here. So according to nodal analysis, first of all we have to identify the nodes. Node, it is a junction where more than 2 elements are connected or 3 or more elements are connected. So I am highlighting the nodes over here. And the fourth node you can see here, it is over here. So out of these 4 nodes, one node has to be treated as a reference node or datum node. So I am selecting this one as a reference node or datum node. Then I have to assign the variable for the voltages which are unknown. So here I am assuming the voltage as Vx, the second node voltage is Vy, and the third node voltage is Vz. I will apply KCL at these nodes and I will find out Vx, Vy, Vz. So let us apply KCL at node X. When you are applying KCL at node X, you have to write down summation of outgoing current is equal to summation of incoming current. Now to node X, 1, 2, 3, 4 branches are connected. And out of the, in one of the current branch you have a current source 3 ampere and that is moving towards node X. So that means this 3 will appear incoming as an incoming current over here. Now remaining currents you can assume as outgoing. So current through 4 ohm can be written as Vx minus 0 by 4 because the one end of 4 ohm is connected to reference node. The rightward current through 2 ohm can be written as Vx minus Vy divided by 2, and current through this 4 ohm can be written as Vx minus 36 minus Vz divided by 4. Now here the LCM is 4, so I will multiply throughout by 4, so I will get Vx plus 2Vx minus 2Vy plus Vx minus 36 minus Vz is equal to 12. I have multiplied throughout by 4 as 4 is the LCM. So the equation turns out to be 4Vx minus 2Vy minus Vz is equal to 12 plus 36, that is 48, and this is my equation number 1. Now I want 2 more equations and that I will get by applying KCL at node Y and Z. So next thing is KCL at node Y, and you have to write down summation of outgoing current is equal to summation of incoming current. To node Y only 3 branches are connected and none of the branch contains the current source. So I will assume all the currents as outgoing. So the leftward current can be written as Vy minus Vx divided by 2. The downward current can be written as Vy minus 100 divided by, here it will be Vy minus 0 divided by 100 plus the rightward current can be, you can write as Vy minus Vz divided by 5 and no incoming current, so is equal to 0. So LCM over is 100, so I will multiply throughout by 100 and this will give me 50 Vy minus 50 Vx plus Vy plus 20 Vy minus 20 Vz is equal to 0. Okay, so one can write down this equation in nice format as minus 50 Vx and then you will have 71 Vy minus 20 Vz is equal to 0, and this is my equation number 2. Now I have to obtain the third equation and I will apply KCL at node Z. So to node Z again 3 branches are connected and none of the branch contains current source. So I will assume all the currents as outgoing, but you have to write down summation of outgoing current is equal to summation of incoming current. So this current can be written as, the downward current can be mentioned as Vz by 20. The leftward current through 5 ohm is Vz minus Vy divided by 5 and current through this 4 ohm can be mentioned as Vz plus 36 minus Vx divided by 4, and there is no incoming current, so is equal to 0. So you can say 3 branches are connected, so 3 terms are over here and 0 term is over here. Okay. Now LCM is 20, so I will multiply throughout by 20, and this will give me Vz plus 4Vz minus 4Vy plus 5Vz, and this will become around 36 into 5, 180 minus 5Vx is equal to 0. The right hand side will still remain 0. So you will have equation as minus 5Vx minus 4Vy, and then you will have 5 plus 10Vz is equal to minus 180, and this is my equation number 3. Okay. So there are 3 equations, and one can easily find out the current, this voltages Vx, Vy and Vz. So you can enter the coefficients and the constants in the calculator, 3 equations, 3 unknowns, and you can find out Vx, Vy, Vz. And Vx answer turns out to be 13.41 volt, Vy 7.06, and Vz turns out to be minus 8.471 volt. You can check this. But the problem is not over. We have to calculate current through 5 ohm resistor, and 5 ohm resistor is over here. Now you decide how you have to move, towards right or left. If you have decided to move towards right, then current through 5 ohm can be written as Vy minus Vz divided by 5, because current is originating at Y, ending at Z, and the resistance is 5. That means current is moving towards right. So you substitute the value, so you will have 7.06 minus 8.471 divided by 5 towards right, and this will give me answer as 3.106 ampere towards. Thank you.